In this video, we're going to be taking a look at our next topic about getting MPLS up and running, and that is actually the Mpls Ldp configuration. Now, there are a couple different methods to actually implementing LDP to get it running. So we have the interface level config, which is the Mpls IP is configured at the interface level of iOS and XC. And then you have the process level, where you use Mpls Ldp autoconfig if you are using ISIS or OSPF. It has to be a link state routing protocol in order for this to work. iOS XR also supports the interface level and the process level, with the caveat being that even if you implement Mpls Ldp autoconfig at the process level of an IGP in iOS XR, you still must enable the Mpls Ldp process in iOS XR. It does not automatically start. So one thing to keep in mind as you're going through your implementation. So at the router IGP level, you simply say Mpls Ldp autoconfig, and then away you go. Now, depending on how you implement it, if you show Mpls Ldp, that'll actually show you the method used to deploy it, whether it's interface level or network process, things like that. There are two different ways to deploy LDP. There are the locally attached. So whenever you do this, it's assumed that your future LDP peers are directly connected. Where again, it falls back to what we talked about in the previous video about how MPLS uses the all routers multicast address 224.0.0.2 on UDP port 646. In that particular case, we ended up connecting to local peers. If I wanted to form a remote adjacency, I would have to specify that information and then be able to connect with that remote peer through the mechanism of a targeted LDP. So what we're going to take a look at in our topology here is we're actually going to go through the process on R1 and XR1. Now, I've already got LDP actually deployed. In this particular case, what I'm going to do is I'm going to go ahead and we are going to, it did it again. Pardon me, folks, while I go. Why is this being difficult at the moment? There we go. All of a sudden now it's not wanting to cooperate. Okay, now that I told it who's boss, hopefully now we're not going to mess with it for the moment. So the way I've got LDP deployed now is if you do a show run section OSPF, we simply have it enabled at the process level. We do a show Mpls Ldp, and at the LDP neighbor, we should have two. Now when we do this, it'll tell you that in this particular case, it doesn't specify how it was deployed. If you do the LDP MPLS interfaces, it tells you here. Interfaces detail. It'll tell you here. It'll say that it was IGP configured. There's no tunneling enabled at the moment. BGP label not enabled. MPLS operational. The MTU is 1500, etc., etc. So that's pretty straightforward for the most part. Now on iOS XR, it's very similar. Go ahead and log in here, and we do a show run router OSPF. You'll see that we have enabled MPLS at the process level here. But if we do a show run Mpls Ldp, it is also deployed globally. In this particular case, I have it logging turned on, so we would see the MPLS neighbor. So if we were to do a show Mpls Ldp binding for 172.16.1.1, let's see, for let's say the 10.1.2.0/24, let's see, oh, maybe IPv4. 10.1.2.0/24. Why is it not working? Bindings, I want to say, oh, that's because I want to do, that's what I was looking for. Sorry folks, I was typing the wrong. So I want to say neighbor of the 172.16.1.1, and I want to see what R1 is advertising to me as labels. So what I'm seeing here is label bindings are propagated through TCP peerings, and if we look at it, we'll see that the 10.1.2.0/24, I know that from this peer, and it's the I use label 24,004 to get there. Now this is the platform-wide deployment, and it says implicit null. Implicit null is an advertisement from R1 to me saying that I own this interface. It's a directly connected link to R1, and this is how I get to where I've got to go. Now, if you take into consideration for something else, like for instance we take the 10.7.8 network. Scroll back up here, 10.7.8, you'll notice that I do have a peering. It's advertised to me from router 1, and this is where it's the unsolicited downstream, meaning that I get everything that router 1 knows about. And he says in order to get to the local label binding is 24,039, but the remote label is 27. So if I was to do a show MPLS forwarding table and look at this, if I look at 24,000 and what was it? I forgot. 24,039 and 27. So if I look at 39, this is my local label, right? This is that's the label I'm going to use to get to R1. If we look at that, the next hop is, in our case, is XR2. And from a forwarding perspective, if I was to look at this same output and say .12 for the, and I wanted to say a particular length, I could type in the 10.7.8.0/24, and it's going to show me that label binding down here, and it's going to use 24,039. But when I do that, if I do label forwarding for particular labels and I specify 24,039, it's going to say in order to get to the 10.7.8.0/24 network, use label value 24,039, but the next top IP is going to be 10.11.12.12, which is going to point to XR2. So from a forwarding perspective, I'm going to forward based off of that. If I do a show IP route for the 10.7.8.0, it's going to tell me that the OSP of adjacency is there. I know how to get there. The route is in the routing table via IGP, right? Now if I do a show IP, in this case here I do a show Ceph for 10.7.8.0 and hit the enter key, what it's going to tell me is I have the route here. I've learned about it. It's an internally routed setup. I learned it in on this interface from this next top IP address, and my local label is this. So I'm going to use 24,039 to get to this destination address, and I'm going to go out this interface to get there. So if I was to do a trace route to the 10.7.8.8 network numerically, the first label you're going to see is 24,039. So notice how it says 24,039. Now this is only transport labels because of the fact that and I get to XR2. If I go to XR2 and I do a show MPLS forwarding table for and hit the enter key, and I go down to 24,039, I receive that label inbound. I'm going to 10.7.8.0/24. I'm going to go to gig 0000.812 to get to R8, but it's a pop value. So if I do a show IP route, or do a show route for the 10.7.8.0, the route is in the routing table. I know it via this next hop. But if I do a show ceph for 10.7.8.0, the local label is this, but the label is imposed, which is implicit null, which is label imposed means that I'm going to pop the label. Says I don't want to route this via I don't need to label switch this anymore because I'm directly connected to that hop. So you're going to pop the transport label, and if I was to forward traffic to it, it would be unlabeled. It would be IP forwarded. So that's how you would do an example. That's how you would recurse that way. So we have that set up, and that's basically how all these are set up. So the that's the breakdown basically of how this goes along. Now we're going to do other views of how this all comes into play. So if we do a show Mpls Ldp bindings from neighbor 172.16.1.12, and we say detail and we hit the enter key, this is going to tell us all the values that we've learned from that particular neighbor, right? And if we say remote label, and I specify a remote label value, so let's say I don't know the actual label value for something, so I could say XR2 is going to use 24.039. It doesn't really give me a whole lot for it because that's if I do a show MPLS forwarding table, I don't use that label. XR2 does. So I don't, but XR2, I can't look at XR2's label database from that perspective. I have to look at it from what I can see locally, because I make my decision locally based off of LDP, but LDP makes this decision based off of IGP. So that's one of the things you have to keep in the back of your mind as you're going forward. Now, one of the things that I mentioned is that I use label value 38. Notice that you've got this guy set up right here. What's happening is I'm receiving a route from my directly connected neighbor here, site 1. This guy is saying I am learning the 20.11.0.0/24 network. This right here is a VPN label. This is coming from the customer. If I was to go over to router 4, or I'm sorry, router 5, not router 4, and do a show MPLS forwarding table, I'm going to have that label here. 20, no, I'm sorry, I won't. I'll have that local. If I do a show IP route for, if I just do a show IP route, I won't have the 20 network in here, but if I do I'm on router 5 and I'm trying to get to site 1. I do a show IP route, or so show BGP VPNv4 unicast all. I'm learning the 2011 network. So if I do a show BGP VPN unicast and I say 20.11.0.0, what it's going to say in this particular output is it's going to say the best path right here is learned from router 3, which is a route reflector. The extended community value of the route target value is 1:1. What you'll notice down here is this MPLS labels. You have inbound, there's no label, but you see outbound, there is a label, which is 38. Which means that if I was to go and do a trace route, and from site 5, site 4 to site 1, on router 11, from a router 11 and trace route from site 4 to site 1, VPN label 38 would be used. Okay. Now, if I said, okay, how do I get to the destination of 172.16.1.1? Because this is who originated the route to me. So now I do a show IP route to 172.16.1.1. So what I've done up to this point is I have figured out who what the VPN label is. This is the VPNv4 output for that. This is the VPN label that has been assigned to the 20.11.0.0/24 prefix. Now I need to know what label do I use in the transport network to get to the destination of the egress PE. In this particular case here, it says that you would go towards router 4 to get there. So I say, okay, let's go and say from here I needed to do now I've done the layer 3 lookup. I know where I've got to go. So I have an outgoing interface. Now I need to do a Ceph lookup. Ceph tells me show IP Ceph for the 172.16.1.1. How do I get there? It says that there's two next hops, one out gig 135, the other one is out gig 1.45. There's label 52 and there's label 30. So what ends up happening is I have to do a show. Now it's saying I have to use a label to get there. So we do a show MPLS forwarding table, and I type in labels. You have to specify the local label first and then the outgoing label. So I could say label 35. Label 35 is going to say, oh, okay, well, you're going to use local label 35 because that's what we see specified right here. I have outgoing label 52 and outgoing label 30. So depending on how IGP forwards the traffic, if I go out towards router 4, I'm going to use VPN label 30. So let's assume for the moment that I use the path towards router 4. So then I go to router 4. I come in here and I do a show IP route for 172.16.1.1, and the recursion process starts all over again. I say, okay, I can get to that, so now I need to go do a show IP Ceph for 172.16.1.1. It says use label 24010, local label is 30. You'll notice that from router 5, I use label 30 here, router 4 sees label 30 coming in, and then it says 24010, show MPLS forwarding table for labels label 30. Label 30 says use 24010 to get to this destination, and then it shoots me out towards XR4. XR4 repeats the process. Show route for 172.16.1.1. It says that I am, I meant to say router XR1. Show route for 172.16.1.1. And this guy says, okay, so there is a route to there, so show Ceph for 172.16.1.1. Ceph is going to say, okay, so you learned 24010, which is what XR1. R4 specified here. R4 specified 24010, which is what XR1 advertised to router 4. So now we're on XR1. We go to XR1 and we see that 24010. It says labels imposed is implicit null. So if we go show MPLS forwarding table for labels 24010, whoops, labels 24010, you'll see that it sees it. It says, okay, local label 24010. It's a pop label, which means we're going to pop the transport label and forward it via the VPN label to router 1. And on router 1, when we look at this, we receive VPN label 38 in. Because no longer, the transport label got popped at XR1. And because the transport label got popped at XR1, we have to forward it towards to router 1 via the VPN label. The VPN label is now exposed. R1 gets it, it says no label, and then you need to forward it out towards this destination, which is an aggregate pointing towards site 1. If I do a show, and it says site 1, and I know it's a VPN route, so what I have to do is I have to type in show IP route VRF site 1. And it says to get out towards this guy, it's a connected route. So if I go over towards R11, I do a trace to VRF site 4 to 20.11.0.1 numerically. Right, grouped up. If I do site 4, what you're going to see is exactly the recursion I walked through. Router 5 gets it, and there's a push. He pushes the VPN label of 38, which we saw on router 5, from right here. He sees that, and then I need to, once that's the VPN label, then I also need to allocate a transport label, which is 30, which is what you see right here. Or 52 in this particular case gets used because of the path that it's going to take. So it takes 52 towards router 3. What's interesting about this though is it's taking the path towards router 3 this time. The path that actually takes is 100% irrelevant. But if we go to 52, if we go to router 3 in this case, and I come in here and I do a show IP route to 172.16.1.1, I have a next hop. I do a show IP ceph for 172.16.1.1. It tells me to use local label 52, which matches this value right here. And then this one, router 3, then says, but I want you to use the outgoing label 24,010. So show MPLS forwarding table of labels of 52. So 52 is received, because R5 is going to use 52 to get there. 52 is received on router 3. I swap it to 24,010 and forward it out the next hop towards router 11. In this case here, this is XR11, or XR1, excuse me. XR1 receives it, 24,010 is received inbound, it pops it. That is why you see a label value of 38 here, a transport label of 52 to get you to router 3. Router 3 receives that, or sends it on, and router 3 says you need to go to swap it to 24,010, which gets you to XR1. XR1 goes ahead and actually pops it, and then the VPN label is exposed, and you go from 38 down to 38 to R1, which gets you to the destination. So actually, if I go to this side and I do a show IP interface brief, that's because I'm going to 100. So that's why it's not showing up. So if I go back over here and I do that same trace route again, but I do 100, that's better. So I'm actually getting one hop further. So you actually get to router 1 the way you need to, but you notice that you'll never actually get to the 38. Doesn't show up by itself. That's okay. There is a way to make that show up, but that's just an example of how the recursion process comes into play. So that's simple LDP. This will get more complicated as we get into MPLS traffic engineering and other factors. The one thing I want to show you now is how to set up a targeted LDP session. So targeted LDP is actually pretty easy for the most part. We're going to set up one between R1 and R5 to show you what that looks like. R1. We go to up here, we type in Mpls Ldp, and we say neighbor, and we specify the IP address is going to be 172.16.1.5, and we say targeted, and we say LDP, and we hit the enter key. Now it's going to start trying to send a targeted LDP adjacency out, but if we do a debug Mpls Ldp targeted neighbors, what you're going to actually see is R5 is not configured to receive the hello. If we also say transport events, we should see that it's not actually going to deny them. So we should see a, okay, right there. If we all here, it says it's going to, right here, it's going to ignore receive direct hello from router 1. So we have to allow that to come through. So if we do a debug Mpls Ldp targeted neighbors LDP or that, and then we do a debug. Which interface was that received in on? That was received in on .45. So debug Mpls Ldp transport events on interface gig 1.45. So if I go on router 5 and I type in Mpls Ldp, what is the command? It's a pretty noisy I believe, what is that command? It is targeted. No, actually, let me jump out of global config and disable this. Disable that, because that's gonna just be no bueno. So if I debug Mpls Ldp targeted neighbors, I go up here, type in Mpls. It is LDP neighbor. No, it is not. There's a, I forget the actual command off the top of my head. LDP discovery targeted hello accept. That's what it was. And then I can say hit the enter key, and then as soon as I do that, we should receive a an adjacency with router 1. So we type in do show Mpls Ldp neighbors. There's the adjacency right there. So the neighbor's up now with router 1, and we did see that come up. So if I hit the enter key here, we go through this. What you're going to see is we have 3 adjacencies. We have one with router 4, one with router 3. Those are directly connected to us. Then we have this with router 1. But you'll notice that we have it in, it's a targeted hello. It's being received. However, it's passive. It is not in, let's see here. I don't have any other ones to give an example towards it. But if I did an Mpls Ldp targeted or neighbor 172.16.1.1, I said targeted, and I said LDP, and hit the enter key, I'd have to do the exact same command over on router 1. Router 1 receives it. It becomes a hello. We do a show Mpls Ldp neighbors. We look at this, and it's active and it's passive. And if I do a show Mpls Ldp bindings for the neighbor of 172.16.1.5, I am receiving labels. So what this proves is I have a targeted LDP session with R5. So it is a multi-hop LDP adjacency, and I'm learning labels. So if something was to happen, it's actually, this is how LDP session protection works. It actually will form a targeted LDP session through a different interface if it's available to be done. And I basically just enabled it by default. Or I enabled it, and what I'm basically doing is I'm receiving labels for values that R5 is advertising to me. And if we look in R5, if we look in here and type in do show Mpls Ldp neighbor or bindings for neighbor for 172.16.1.1 neighbor, you're going to see that R1 is advertising this, and if we do LDP neighbors, we're going to see that we have a peering with router 5. It's active and it's passive, which means it's sending and receiving. So that's telling me that I'm both sending and receiving information from router 1. This is how we're going to get into things like MPLS traffic engineering when we set up stuff like that. So that's one of the basic reasons here. Now on the from this perspective here, if I wanted to go to XR2 for instance, Let me log in here real quick and do a show run Mpls Ldp. I know I showed you this already. This enables this guy. So if I wanted to do the same thing with router 5 to router 1 or to XR1, actually XR2 neighbor or Mpls Ldp neighbor targeted or 172.16.1.2 or 12 targeted an LDP and went to XR2 XR, it's trying to set it up, and on XR2 if we went to config T and we type in router or Mpls Ldp and we typed in neighbor of 172.16.1.5 and we said targeted and hit the enter key, and then we commit because R5 has been allowed to form the adjacency. The connection is up. It did pop in do show Mpls Ldp neighbors. If we look through here, we should see that we have a pairing with router 5 and it's unidirectional. Or, I'm sorry, it's bidirectional. So R5 has one with XR12 or XR2 and with router 1. So we have got targeted sessions up, and if we do a show Mpls Ldp bindings from neighbor 172.16.1.5, we're going to see a bunch of information coming through, which means that I have two active adjacencies that are more than one hop away. And that's what I really wanted you guys to see, was the local and the remote bindings. So you can do both local and remote and not have to do anything extreme in order to get this stuff to work. So that's some of the basic conceptual aspects of it. We're going to get into more complicated designs as we get further along and stuff like that, but from right now, this is the more or less the core fundamentals that I wanted you guys to be able to pick up on. So we're going to talk about filtering and how we can do more advanced capabilities with this, but for just doing basics, like I can come in here and I can specify like this command right here. If I wanted to, I could specify if I was to go to I believe it is label, no, it is local. There's a command in here, I gotta remember what it is. It's address family. Address family, IPv4, and if I was to go underneath here and type in label and say local, and I could start filtering out who I want to be able to advertise. I could start filtering out who it is that I want to talk to, how I want to talk to them. We're going to dig into these as we go along. I could say allocate for, and I could specify who it is that I want to be able to allocate routes to. We're going to get into a lot of the filtering down the way, and we're gonna revisit a lot of these same techniques again, but I wanted to show you them without any advanced features, and then how you could apply advanced techniques like filtering and static labeling and the advanced capabilities of that. But we'll get into those as we go along. Until next time, guys, thank you so much for stopping by, and we'll catch you guys in the next video.